Alright guys, welcome back to this channel, and in this video I'm going to be showing you how to use epsilon definition to show that this limit actually converge to 0 or for any b in R. Okay, so if you are new to this channel, this is BAM Scissors Academy, where we solve math related questions. And yeah, do well to click on the subscription button so that you can always know when videos drop on this channel, and also to encourage um, what we do here. So let's go straight into getting this done. So first thing you want to know is how to write the epsilon definition. So you want to know that for all epsilon greater than 0, there is n by epsilon in n such that the absolute value of xn minus L is less than epsilon, right? For all n greater or equals to n by epsilon. So once you know this, then the rest of the matter is just very trivial. So just plug them in. I have my absolute value. What's my xn? That's my n plus b over n squared minus 6 minus 0, because that's our limits, minus 0 less than epsilon. Okay, so I actually want to achieve this condition. Can achieve this, I'm good to go. Okay, so yeah, minus 0, that's obviously n plus b over n squared minus 6, which is less than epsilon. Okay, so now let me deal with the denominator first. I want to find a particular sequence that will be less than this so that I can compare it accurately with my epsilon. So what I would do in this case is that if I want to make the whole of this if I want to make the whole of this expression, the whole of this series to be less than another thing, that means that uh, this one here has to be greater than the next one I'm trying to compare it with. This is what I mean. I mean that if I want to compare, I can now have my um, absolute value of n plus b over n minus n squared minus 6 will make sense if it is n plus b. As a matter of fact, I can use my triangular inequality where we have a plus b, okay, is actually less or equal to absolute value of a plus absolute value of b, right? So I can actually use that. So let me add my absolute value here. That one is settled anyways. Then for this one, it will be less than n squared minus n squared over 2, obviously, because n squared minus 6 is greater than n squared minus n squared over 2. So that means since we have a larger denominator, then it will be less than the other one I'm comparing with. So I can say this is actually less than what? My epsilon. Then we move from there. Okay, so what we'll have something like this: n plus absolute value of b over, if I should subtract this one, I'll be having n squared over 2 less than epsilon, right? Okay, so let's bring together the whole expression and get our answer quickly. So if I should do the whole calculation here, I'll be having something like 2n plus 2b over n squared, right? Is less than epsilon, right? So in that case, I will just have 2n plus 2b less than n squared epsilon. So what do I do? Then s squared epsilon minus 2n, then plus that'll be minus 2b, right? I'm trying to bring everything to the other side. Minus 2b, then everything will now be what? Greater than 0. What does this look like? This looks like a quadratic equation. Then I can now finish up whatever I want to do from there. Okay? So using quadratic formula now, don't forget that x is equals to minus b plus or minus square root of what? B squared minus 4ac over 2a, right? And here, my a is this is b, this is c. Just simply put, so if I want to fix it in, that will be n greater. What's my b? My b is minus into minus 2 plus or minus square root b squared minus 4. What's my a now? Epsilon times c. What's my c? Minus 2b, right? Then over 2a, which is n greater than what? 2 plus or minus the square root of 4 plus, what would that be? Plus 8 epsilon b over 2 epsilon. Okay, so with that, we can now have n greater than 2 plus or minus, I can actually bring out 4 from here. That would be 1 plus 2 epsilon b over 2 epsilon. And if I should bring that out, that would be 2 plus or minus 2, 1 plus 2 epsilon b over 2. So if I should cut that out, 2 plus minus, sorry, that would be 1 plus or minus square root of 1 plus 2b epsilon over what? Over epsilon. And we've been able to achieve this particular condition. Very easy. So this is to say that the limit as n plus b over, as n tends to infinity of n plus b over n squared minus 6 actually converges to 0. Thanks so much for watching, and don't forget to like, share, subscribe to this channel, and I will see you in the next video. Bye for now.